All right, so today we're going to start building a power supply for the Atari ST. As you probably saw in the last video, I was sent an Atari ST by one of the viewers, but unfortunately I did not get a power supply with that computer. So I've decided to go ahead and build one instead of trying to find an old one that probably didn't work very well. You know, if you buy used power supplies that were made 40 years ago, they're probably not going to work too well. So I've got here a printout that I downloaded from online that has the actual pinout of the Atari ST as you're looking at it from the computer. So if this were the back of the computer, this is the pin, and we need plus 5 volts and minus 12 volts and ground. So what I've done is I have a power supply that I've had for a while. It's brand new, haven't really used it. It's made by Meanwell. These are very common. You can find these online in different voltages, but this is a very popular one. I used to use these a lot in equipment that I used to work on. And you can see this one's got 5 volts at 7 amps, 12 volts at 3 amps, and minus 12 volts at almost half an amp. All right, so we're going to go ahead and we're going to use this power supply to create our Atari ST power supply. So I went ahead and wired up some mains to it, ground, neutral, and hot. Got a main cord here that I've salvaged from an old power supply. So I'm just going to put that to the side for a second, and we're going to talk about this actual connector on the Atari. I went online and I ordered this DIN connector. This is a 7-pin female DIN, and it has the solder pins on it. All right, it comes with everything you need. It comes with the strap to actually hold it in place, a rubber boot, and a little screw. And they kind of come like this in a package, if you're wondering. Okay, brand new. So what we're going to do is I've also ordered some 22 gauge copper wire. It's got, I believe, 4 conductors. And we're going to go ahead and use this to build the actual connector that goes to the Atari. So I'm going to go ahead and solder this up and let you follow along. I'll speed it up at certain points if necessary so you don't get too bored. And then we'll test the output and make sure that we've got the right voltages and the right pins. Now, it's important to keep in mind that this is looking at the computer. So if this is the plug that's actually going to mate with that connector in the computer, make sure you keep your pins in line. So 5 volts and 5 volts would not be these two looking at it from this side. It has to be from this back side, because you have to imagine this is going to plug into the Atari ST this way. All right, so we're going to have 5 volts here, 5 volts here, plus 12 volts here. This bottom pin is not connected. And then we're going to have these 2 pins grounded and our minus 12 volts here. All right, so with further ado, let's get started. All right, so now that we've got the cable with the end on it, let's go ahead. Now I've gone ahead and I've cut this length of cable pretty long. I'd say probably 6 to 10 feet. So I've got enough room on the other side for connecting to the power supply, because later on we're going to print a 3D printed case for this power supply. We'll do it in some nice PLA to hold this, and this will be sitting on the ground most of the time with the power plug. And then I've got plenty of extension here to reach up to the Atari ST, so this is never in the way. It'll always be on the ground. So now that I've got this length cut, what I'm going to do is, before I connect it to the power supply, I'm going to slide this metal cover up. This is obviously the grip of the connector right here. Okay. And before we do anything, as far as buttoning this connector up, I'm going to go ahead and connect this end to the power supply so that I can test my connections and make sure everything's right before I close this thing up, you know, put the cable protector on and button it up. I'll show you how we do that. So let me strip this and connect this here real quick, and we'll check our voltages here at the end. Probably should plug this thing in and test and see which voltages are what before I do anything, so I know exactly what's what. Lay this down so you guys can see it. So in this power supply, here's our ground. Our common for the DC is actually right here where it says common. So V1 is going to be our 5 volts. Just take a note of that. V1 equals 5 volts DC. V2 is actually the positive 12. And that means V3 is going to be our minus 12. Okay. Get that guy out of the way. Let's unplug power supply. And let's get this end stripped back a little bit so that we've got some room to actually get in here and do what we have to do. Okay. Now this is why I labeled these wires earlier when I connected the ends to here, because now I know exactly which of these go where. And we're actually going to tin the end of these before we connect them to the power supply. Always tin your wires, guys. It gives them a little bit of a strength, especially when you're dealing with braided wire like this here. Turn on the soldering iron again, which I had already turned off, fortunately, but it is a Hakko FX888D, which heats up literally in seconds. If you guys are interested in some of the equipment that I use here, let me know. I'll put some links in the videos where I use them so you can actually go check them out. All right. Let's get some of these wires tinned here. All right. I think I had neglected to turn on one of my lights here, so tell me if this makes it look a little better, guys, on the video. Yeah? Okay. All right, so our power supply is unplugged, so we're not going to get the crap shocked out of us. So let's go ahead and connect our wires to the power supply. So I'm going to start with the common first. Let's get the AC lines out of the way. Let me put something under this to prop it up where it won't slide. A little bit bigger Phillips. So here is the common wire, which is our black for ground. Slip that in behind the plate. What's nice about this power supply is it has the screw, and then there's a flat plate behind the screw that actually clamps down. So a V1, which is right here, V1, I don't know if you guys can see that. If I put a light there, V1. V1 is our 5 volts DC, and our 5 volts DC is the yellow. So yellow is going to go to V1. Again, this is why I wrote down which colored wire went where when I was putting the end on the DIN connector. Last thing you want to do is feed the wrong voltage into the ST. You don't want to put 12 or 5 or 5 or 12. All right, so V2 is our plus 12 volts, and our plus 12 volts is red. So we're going to go over here to V2, put the red connector there. And then last but not least, which is our white connector, which is our minus 12 volts. We said that was V3, and V3 is right here on the power supply. So there we go. I don't know if you guys can see that very well. This camera doesn't autofocus that I'm using, but we've got ground and then our 3 right there. So now what we can do is we can use our multimeter and we can check the voltages here for what we think they should be. So if this connector we're going to plug into the Atari right now, we should have, and if I orient this correctly based on the diagram, like so, we should have 5 volts here, 12 volts here, and then so on. So let's go ahead and plug this in. I want to make sure none of these are touching. All right. Let's plug our power supply in. All right. Power supply is plugged in. We've got a green light. Got the voltmeter here in front of us. And just to make things a little easier, I'm going to tie the ground wire of the multimeter to the common on the power supply so I don't have to hold that. Okay, so now I've just got my test probe here, and I can see here on the power supply, I can check it. So we said that our yellow wire was 5 volts DC, plus 5 volts DC, and that is coming up here on the first pin, looking at it from this angle. That's our yellow wire, so let's check that, and we've got 5 volts, so that's a good sign. 5 volts. All right. Then we've got plus DC on the third pin down from the left, which is our red wire. And did we do that right? Ooh, I think I made a mistake here, guys. You see? This is why we test before we connect. I actually have the yellow 5 volts DC in the right place, but then I've got this 12 volts DC over here. I don't know if you can see it. See the 12 volts DC, which is supposed to be under the 5 volts DC? The 12 volts DC I made a note as red. Guess what I did over here? I put yellow. So if I check this here, what do we actually have? I've got minus 12 volts. So I wrote it down here on the paper incorrectly. But that's okay, because rather than reverse the wires here on the connector, I'm going to change my notes, and I'm going to say the white is actually going to be the plus, and the red is going to be the minus. And all I have to do is change it on the power supply. So let me do that real quick. So let's unplug the power supply. All right, that's off. The green light is off. And I'm going to swap the yellow. I'm going to swap the white and the red. So let's take the white out of V3. Take the yellow out of V2. put the white over here. All right, let's plug our power supply back in. Now, we didn't move our yellow wire, so that's going to obviously be our 5 volts. Now, our white wire is going to be plus 12 volts on the right connector on the pin, which is the third one down from the left. Let me get this where you can see it in focus here. And there we go, plus 12 volts. Plus 12 volts, plus 12 volts. That's what we want. And going down in the center pin, we're not using that one, which was this one right here. That one's not connected. And then wrap around over here to the red, which is going to be our minus 12. And it is. And then all the way up over here, which is ground, which we know is ground, is going to be 0. All right. So now that we have this connector wired correctly, what I like to do before I even think about buttoning this up, well, first of all, let's unplug the power supply so I don't get shocked. And what I like to do is to make sure that these wires never touch in the future, is we're going to put a little hot glue in here. All right. So what I do is I've got a hot air gun as part of the tools on my workbench. Again, if you guys are interested in seeing some of this stuff and what I'm using, I can either do a video on it or I can create some links, share those with you in the bottom. But just take a hot glue stick, get some hot air. If you've got a hot glue gun, that works too. But I like to put just a little bit of hot glue in there to protect these things from coming off and, you know, something getting in there and contaminating, making them touch. Heat this up a little bit. All right. Put that back up there. And let's just dab a little bit of this glue in here. You don't need to put too much, but just enough to get some coverage in there. All right. Let that dry a minute. Okay. All right, so now we're at the point where we can actually put this stress relief on here. And the way we're going to do that is this guy snaps in here in this little channel. Let me turn this air gun off so you can actually hear me. This little guy snaps in here. Let's see, how does this guy go in here again? Be careful with the hot glue that it doesn't prevent you from putting this piece on after the fact. So this guy goes like this. And basically what we want to do is crimp this connector. Where are my pliers? Missing my pliers. Don't know where my pliers are. They've grown legs. I'm going to go ahead and use the tin snips for now. Actually, no, I don't want to use the tin snips. Those might be a little too harsh. Hang on one second. Let me find my little pliers, guys. All right, I think I found them. So anyway, let's get back over here. And let's bring these guys in. You can see this guy is kind of like spring loaded here to keep tension on this connector. That's probably good right there. Let's give this an extra little turn down. Okay. All right. Then we're going to go ahead and slide this metal piece up. Now there's a hole here on this, the tang of this metal piece that we just put on that has a screw. And that screw goes into the screw of this case. So basically we're going to slide this guy down. I think that hot glue might be interfering a little bit with this connector. Let me come back out a little bit. You see here. Are you preventing us from going in there? I don't think so. But it could be. Does that look straight? Yeah. It's a little crooked. Just a little bit crooked. I think it might be these actual tangs that need to be bent inward a little bit. Let's see if that helps. Let's try putting the screw in and see what we get. Get a little bit of a thinner, where did that thin Phillips screwdriver go? There it is. Let's see if we can get this guy in. Is it reaching? Is it not threading? Why is it not threading? Hang on a second here. Let's make sure the threads on this are not goofed up in any way. Nope, definitely threads. So I think what's important is that when this connector goes in, this has to be nice and straight across. So I'm just going to bend this up a little bit. There, we want to have that as straight of an angle as possible so that when this cover comes on, that screw has got just the right amount. It's actually a little crooked this way too, if you can see it. So let's bend it back that way a little bit. All right, let's try. You got to kind of play with it a little bit to get it right. All right, see if we get our screw started now. Yep, that's it. It's a little crooked up here at the top still. I'm not really sure why. I think it might be having to do with a little bit of that glue in there. But I think it's going to be fine going into the computer. All right. Now there is one piece that I forgot to put on, which is this plastic sheath that goes right here. So I'm going to disconnect the power supply one more time off camera, and I'm going to slide that up on there so we can see what the final product looks like. All right. All right, so anyway, guys, this is the finished connector. I can tell you, to be honest with you, getting this boot on was pretty difficult trying to push that in there, but I did get it on there. Anyway, there's the connector. It looks pretty good. I think it's a little crooked here on this end, but I think over time that'll work its way straight. I think a little bit of that hot glue just is putting a little pressure on one side, because if I take my screwdriver in here and just push a little bit, it straightens right out. So I'm not going to be too concerned with that. I'm not going to play with it too much. It's a very strong connector. I recommend you get the ones like if you're going to do this yourself, get one that has a metal housing like this. It's just more robust in putting it on and off. So yeah, we got the connector. We've got the power supply. I'm going to connect these ends back to the power supply, and for all intents and purposes, this part is good to go. So let's take a look over at the ST now and see what was wrong over there. I think the power switch, there was a note on the computer that said the power switch was stuck. So let's take that apart and take a quick look at that and see what's going on with that. All right, so here we are at the Atari ST, and you can see here, the sticker is still on here, broken power switch. Now, this power switch, I don't know if it's actually broken or if it's just frozen, but it doesn't move. It's pretty much stuck right there. You can't move it. So instead of trying to force it and see if I can break it free, we're going to go ahead and take the computer apart and look inside it and address that power supply. And then obviously in some future episodes, we'll talk about this particular model is an Atari 520 STM, okay? And that little M at the end of the 520 ST stands for modulator. This particular model has an FM modulator for the TV. We're not going to be using that, but I just thought I'd let that little tip be known. Looks like we're missing a foot right here. So we're going to have to order some feet, probably replace all 4 of them at some point. So let's get these screws out and see if this Atari has been opened in the past. You can usually tell by if the RF modulator has been removed or if the pins that hold the RF modulator together have been bent. So I think we've got, let's see, 1, 2, 3, 4, 5, 6 screws out. Let's turn this over and see if the lid comes off. Should come off pretty easily. Is this tape holding the keyboard on? Let's take the tape off. We don't need that there anymore. Yeah, it was actually holding the keyboard to the case. And so this upper case comes off. Put that to the side, and yeah, this is pretty dirty inside. Look at that. Years and years of dust. So this looks original inside. You can see this piece of tape right here is still holding the keyboard harness down. So we'll go ahead and lift that up. Looks pretty stock, guys, which is nice. All right. Keyboard's held in by one connector right here. Pops right off. Set the keyboard off to the side. And now we've got to deal with this RF modulator. So this is what I was talking about before. You see these little tangs right here? There's a tang there, a tang there. These are actually bent in place at the factory to hold that down, obviously along with the screws. Let's go ahead and take the screws out, and then we'll bend those tangs back. That will allow us to get the RF shield. If I kept calling this the RF modulator, I meant to call it RF shield. There's the RF modulator that connects to the TV. This is called the RF shield, which was put there probably because the FCC required it to keep interference from the computer to the television and vice versa. All right, so I've got the 3 screws out. Now what we have to do is bend these tangs straight. Like so. And once we bend them straight, we'll be able to lift this out of here. With a little forceful persuasion, there's some more tangs over here on the side. A little bit more challenging to reach, but we can make it happen. We've got 2 more on this side over here. Okay. All right. And we should be able to separate this RF shield from the main board. Now, are there any screws in the back here holding this? Doesn't appear to be. I think we might have to lift this board out of here to get the rest of the shield off. I think that's probably what we're going to have to do. Let me just make sure I didn't miss any screws back here. No. I'm hoping there's no screws under this label. I don't think there are. No. So, I think it's just a matter of getting this away from the main case. Should be able to lift it out of here. We don't want to break anything. Actually, is there a screw there? No. Oh, there's one more screw, guys. Actually, there's 3 more screws. One here, and one here. Couldn't see them until I actually had to bow the main board a little bit to see those. No worries. I can tell you back in 1986 or 1987 when I got my first 520 ST and had it apart, probably had the same issue back then, but I was a lot younger and stupider. So let's see if we can lift this out of here now. Yep. All right, so now what we're doing is we're lifting the entire board with the RF shield. We'll take the base out of the way for now. And yeah, so we can see up here we've got another tang clip that's holding this side and another one on this side. And to be honest with you guys, like I do with my other Atari computers, I usually do not reinstall the RF shield because I'm always going into these computers and tinkering with them, so probably won't be putting it back. I do keep them, obviously, because they're parts of the original computer. I just don't install them back on the computer. And it's not a big deal. Some people kind of get a little weird about that. And actually, there's one more tang down in this hole. They really didn't want this RF shield coming off very easily. All right, there we go. All right, goodbye RF shield. And here is the beautiful Atari 520 ST original motherboard. And let me get the model name correct, Atari 520 STM, because we have the RF modulator. Now, this is the switch that is stuck for whatever reason. I've actually never run into this situation before with one of these switches that are stuck like this. I don't really understand why it's stuck. Tell you what, let's spray a little deoxit on it. Let that work itself in there a little bit and see if by some magic it frees itself up. I don't think it will. Very strange how that is in a stuck position like it is, but you know, stranger things have happened. Definitely does not want to move. I guess we could probably take that switch apart and see what's going on inside there. Looks like this actual rocker piece here, the black button, can be removed. If we stretch this out a little bit, we can get this actual switch mechanism to come off. Not sure if I want to do that, but at this point, I really don't know what the option is. We could order a replacement, I guess, if we could find a replacement. Just don't know if they exist. I'll tell you what, why don't we, I think what may have happened is I wonder if we could pull this plastic off of here and get access to the actual switch mechanism. See if I can get this plastic switch off of here without breaking anything. It looks like this tang can actually be bent outward. There we go. But now we're left with just the switch mechanism itself, and it's pretty frozen. I don't know if you guys can see that. It looks like a small toggle switch. Okay, it's like a small toggle switch that's made to go up and down. But it is literally just frozen in one position. Well, I think I actually moved it that time. I forced it to move. I don't know if that was a good thing or not. Okay, it's actually switching now back and forth. It may have just been. Let me hit it again with some deoxit. Boy, this thing is going to need a little compressed air to get the dust out of it. But I don't know if you guys, let me move the light a little closer here where you can maybe see what I'm doing. Now, this little switch is actually toggling back and forth now. Okay, so we may have corrected the problem. I'm going to go ahead and put the plastic switch housing back on it. Yeah, it's actually functioning now. I think we may have gotten what we needed to get gotten. We may have gotten done what we needed to got done. So at least the switch is actually working now. Let me see if I can bend these tangs back a little bit so that this switch is a little tighter. So this plastic housing is literally just a rocker for this toggle switch. So I'm going to bend the tangs tight so that when I put this back on, it holds. Okay. It still feels a little wonky, but I think at the end of the day, it's probably going to work. Let's pull out our, I can't talk today. Let's pull out our multimeter and put it on continuity. Actually, let's put it on beep. And let's see if we can't test the switch to see if it's actually working. Now there's 3 legs to the switch, so I'm assuming that when the switch is in one position, we've got continuity, and then when we turn the switch, we'll have continuity on the other leg. So right now, they are all, if I go meter to meter, we're good. Meter to one leg, middle leg, nothing. Middle to the first leg, nothing. Throw the switch, we got nothing. We got nothing on the connection. So, I'm not sure if that means this switch is dead or if I'm looking at this wrong. I don't think I'm looking at it wrong. I just don't think the switch is working. Interesting. Okay, now I'm getting the connection. So that's off. And then when we throw the switch, it probably connects these middle two. Okay, yeah. All right, so right now the switch is off. I've got no continuity. I throw the switch. Oh, did I speak too soon? I got continuity. Yeah, it's just dirty connections on the board. So off is off, on is on. So I think we're okay there. Probably want to touch those solder joints up. All right, so I think we have a working switch now. I think probably what we'll do now is, let me get this motherboard over on the computer table. We'll take the power supply that we just built, we'll connect it to the computer, And the monitor that I got with the computer, I don't know if it's working yet, but we're going to go ahead and plug everything up and see if we can get this thing to come alive. So stand by. All right, guys, we're back. And as you can see, I've got the Atari 520 ST on the desk here, and I've got it connected to the Atari SC1224 monitor that I received in the mail with the 520 ST-M. And you can see there's the power supply that we built today. And it's connected, and it's got a long cable that goes up here to the ST. That's the cable we put together. There's our monitor cable. There's our ST. We're going to go ahead and power this thing up and see what we get. All right, guys, keep your fingers crossed. Here we go. Looks like I had to jiggle that switch there a little bit to get it to come on, but we are getting a video signal. That's a good sign. And there we go. We've got the GEM desktop running on top of the TOS, which is the operating system. You can hear in the background that noise. If I turn the volume up on the monitor, you can probably hear it. I don't know what that noise is. I don't know if that's being generated by the monitor itself or it's being generated from the Atari computer. But the good news is that we do have a working computer. Let's check that switch one more time. I'm going to throw it off. Okay, so we know that it turns off. Now, when I first turn the switch on, it doesn't actually activate. If I touch it just a little bit, so that tells me that switch is bad. Still has a problem, but at least it's functioning to a certain degree. Let me try it one more time. So maybe it'll get better over time. If you guys know of a replacement switch that can be used to replace this, I'd rather do that than monkey around with this one. But anyway, there we go. So the good news is we did accomplish something today. We've got a power supply. We fixed the power switch. So we're on our way to having a working 520 ST. And by the way, guys, let me take this camera up so I can show you guys something. I believe this board has already 1 megabyte of RAM because we have, let's see, 2, 4, 6, 8, 10, 12, 14, 16 chips. So that's a total of 16 bits. I think that's 1 megabyte of memory, if I'm not mistaken. You guys can correct me in the comments if I'm mistaken. It's interesting how we've got these clips on top of these two chips here. I know one of these is a glue chip, and I'm not remember what the other one is. There's the MC68000. We'll do another video where we go over the layout of this motherboard and of this computer. But anyway, thumbs up. We've got a working ST, so we can continue on the project at a later date. Guys, I cannot wait to get this ST working. There's so many games, so many programs, so many cool things we could do with this computer. You know, this is the computer I upgraded to, the Atari 520 ST, after I had started out and gone through the 8-bit computers. I had an 800, then I went to an 800 XL, and then I went from the 800 XL to the 130 XE. And at some point, I graduated from the 130 XE to the Atari 520 ST, and then ultimately a 1040 ST. So just repairing this computer, seeing it turn on for the first time brings back a ton of memories from when I was a kid and learning computers and how to program them. And the Atari was instrumental in making me what I am today with respect to programming, interest in computers and electronics, etc. So hope you enjoyed the video. Stick around. There's going to be maybe another part 2 and 3 as we continue to fix the ST. We've got to get rid of that annoying sound. We've got to check the disk drive, clean it up in general. And once we have it together, we're going to look at some software on it. And I haven't forgotten about the 8-bit world. I'm working on some material for that as well, some assembly language programming. So stay tuned.